Hey guys, so we are going to go ahead and start with the first section of Chapter 8. As I'm starting here, I just do want to preface this with, I've never actually made a video like this, so if it sounds weird or if my handwriting sucks, I apologize, so please just bear with me. But let's go ahead and get started. I'm just going to bring out my, inner YouTuber that never existed. But we are going to be talking about polynomials in Chapter 8. And that's basically any of these expressions with multiple terms in it, with like x terms and x squareds, even x cubed, as you'll see down here. But let's start with this one. So for factored form, as you guys know, that means we are going to want to do box and diamond. But before we do box and diamond, I want you to notice that there actually is a common factor that we can pull out of here. If you look closely, you'll notice that all of these terms can be divided by 2. So we can actually rewrite this after we pull out or factor out a 2. So we can say, okay, well, it's 2, and then 2x squared turns into just x squared because we divided out that 2. 2x turns into x. And negative 12 divided by 2 is just going to give us a negative 6. Okay, so this is our new version of that. It's just going to make it easier for us to graph it and then factor it. So now that we did that step, we can go ahead and do the box and diamond that you guys are super familiar with. This box is going to be a little rough. Okay. So as usual, remember we're focusing on this piece right over here, not the original problem. So our first term goes in the top left box, which is x squared. Our third term goes in the bottom right, which is negative 6. And we need to figure out what goes in these other two boxes. So we are ready to go ahead and do the diamond now. So the top of the diamond, remember, is first term times the third term. So first times third, that's going to give us a negative 6x squared, and the middle term goes in the bottom of the diamond. I'm going to go ahead and write 1x, even though it just says x, just so you guys are clear that there is a 1 to consider there. And now you get to play the game. So what two numbers multiply to make the top and add to make the bottom? We'll notice that that's going to be 3x and negative 2x, because 3 times negative 2 is negative 6. 3 plus negative 2 is 1. So now that we know that's correct, we can go ahead and fill in the rest of our boxes and use that information to fill out the outside. I'm kind of just going through this a little bit quickly because we've already done this many, many times. So as we go to rewrite this in factored form, you guys might be inclined to just do what you're used to, which is this. However, please don't forget that we just factored this piece right over here, so don't forget about that 2 that was there. We still have to keep it. So this is going to be our factored form. Technically, that should be a f of x. Right, so now that we have our factored form, we know that, from previous chapters, when you have your factors and set those equal to 0, those are actually your x-intercepts. And so we know that our graph, our parabola, is going to hit our x-axis at positive 2 and negative 3. You can just take the opposites there. So we got positive 2 right over here, negative 3 right over here. And that's about as specific as I'll require you to go on the graph for now. Of course, your y-intercept is going to be actually at negative 12, so this graph is going to be pretty long, but we're just going to go ahead and make a little sketch here. This is going to be a little rough. But, alright, so that's our sketch of our graph. So it's not super new stuff, but the new stuff is kind of going to be now. It's a lot of vocabulary. So when I ask you for the degree of a polynomial, okay, that's going to be talking about the largest exponent on an x term in your polynomial. So when you look over here, you're like, I have an x and I have an x squared. Which one of those has the biggest exponent? Well, it's going to be this guy, and that exponent is the degree. So I know that because it is a 2 on that term, my degree is going to be 2. And that's because it's the highest exponent. Okay, so that's a degree. All right, the next vocabulary term here to keep in mind is a coefficient. I think we've probably talked about coefficients before, but what that's going to be is the number in front of your variable. So every term that has some kind of x in there has a coefficient, and that's the number in front. So the coefficient here is 2, the coefficient here is 2. This number on the end is a different vocab term, so that one is not a coefficient. So for us, our coefficients are 2 and then 2. They're not always going to be the same, so just keep in mind that they're only both 2 because both of these happen to have a 2 in front of them. And we can say here, just take a note, that these are the numbers attached to our variables. Okay. So that brings us to the leading coefficient. So this is also a number attached to the variable, but the thing about the leading coefficient is that it is going to be the one attached to your degree term. So while both of these have coefficients, your leading coefficient comes from the term that has the x squared, because that's the term with the degree. So basically, it's the coefficient on the term with the highest exponent. For us, that is still going to be 2. Just know that it's this 2 and not the second one. So our leading coefficient, again, is going to be 2. It probably would have been better to have an example without same numbers, but again, just keep in mind what that really means. And we'll make a note here that it's the number attached to your x with the degree. I'm just going to write with because I don't have a ton of space. Number with the degree term. That brings us then to the constant term. So a constant term is the number that doesn't have, or I guess the term that doesn't have any variable in it. So these two have x's in them. This one, this little -12 is just hanging out by itself, and that is what we are going to call our constant term. Because it's just a number, it doesn't have any variables with it, so it will never change. It will always stay constant. Term without a variable. Right. So your constant is never ever going to have an x associated with it. So this next example is actually a cubic function. If you'll notice, this has an exponent of 3 rather than the 2 that we're used to. And so this factored form, you guys aren't really familiar yet with how to factor cubic functions, but there's actually a trick to it that we can use our calculator for. So let's just go over here to our calculator, and we can go ahead and type it into our y equals. So let's just go ahead and type our x cubed minus 13x squared, oops, minus x plus 13. Okay, we got our x cubed minus 13x squared minus x plus 13. Let's see what our graph looks like. So the thing you have to be careful about, now remember, factored form always, well for now, as far as we know, shows us the x-intercepts. Just like in this example over here, we knew based on these factors that our x-intercepts were going to be at 2 and -3. So here we can tell that there's going to be x-intercepts right here, so we already have an idea of what some of the factors will be. However, the fact that the degree is 3 tells us that there actually should be a third x-intercept. That's something that we'll talk about even more in detail a little later, but it's something to keep in mind. The degree tells us how many x-intercepts or roots that we're going to have. So this isn't quite showing us everything, so I'm going to go ahead and go to the window, and I'm going to make it show me more values on my x-axis. So I'm going to say the maximum number on my x-axis, I'm going to go ahead and change that to, let's go 18, see if that helps me at all. So that just shows me the x-axis up to 18. So if you see, now I see all 3 x-intercepts on the same graph, so we can use our second trace function to find them. All the way from chapter 1, if you click on 0, remember those are pretty much the other name for your x-intercept. So we're going to go ahead and play that left-bound, right-bound game. So on the left, we're going to find this intersection first. Go to the right of the intersection. It disappeared, but we know we're somewhere to the right. Press enter, enter. It tells us that we have an x-intercept at -1. So right over here, we're like, okay, one of my factors must be x plus 1. Remember, we always take the opposite. Okay, and here we could do the same thing, but because we're in like a pretty standard Zoom format, you can see that the other one is going to be just at +1. So we can say that another factor is going to be x minus 1. You just got to take the opposite there. Now for this one, let's just go ahead and do our second trace menu again. Go to 0 and play the left-bound, right-bound game. Just go until you can see your cursor show up anywhere to the left of your intersection. Alright, so the cursor's struggling a little bit here, but this is going to be on the left. I know we can't really see it because this is such a steep line, it's going to be really picky about it. We'll go here, and then we'll go farther to the right. And you can also count the tick marks. Remember, if you're in like a standard Zoom, you can count the tick marks, and you'll find that this intercept is at 13. So our final factor is going to be x minus 13 because we have an x-intercept at +13. Alright, and if we are to sketch our graph, we're like, okay, there's one at -1, +1, and 13 will be all the way over here somewhere. For simplicity's sake, we'll just stick it right there. And kind of just, you know, imitate the graph you see on your calculator. It's not going to be perfect by any means. Mine is especially going to be a little rough, but we're just gonna let that go. So again, this is really ugly, but you get the point, hopefully. All right, so now this portion is just like we did above. This degree of the polynomial is going to be the highest exponent on an x. So for us, that's going to be this term right here, and the exponent itself is 3. For coefficients, it's the number in front of all the terms with an x. So here, our coefficient, there's just going to be an imaginary 1 wherever there isn't a number, so like in these two spots. So we know we have a 1, we have a -13, and we have a -1. Our leading coefficient belongs with the x cubed because that's the one that has the degree in it. So 1 is going to be our leading coefficient. All right. And then our constant term is going to be 13 here because if we look at our problem, 13 is the number with no variable.